So, hello everyone. By Tezos Foundation. Till now, we have discussed about what is blockchain, what is introduction to blockchain, introduction to Tezos platform, and what are the Tezos protocol. We have also discussed about mining and transaction. So, if anyone of you is having some doubts related to yesterday's session, then you can ask in comments. We have our speakers right now here. They can answer your doubts. If you're having any doubts, please ask in comments. So, everyone, uh, by Tezos Foundation. Till now, we have discussed about what is blockchain, what is introduction to blockchain, introduction to Tezos platform, and what are the Tezos protocol. We also discussed about mining and transaction. So, if anyone of you having some doubts related to comments, we have our speakers right now here. They can answer your doubts. If you have any doubts, please ask in comments. By Tezos Foundation. Till now, we have discussed about blockchain, introduction to Tezos platform, and what are the protocol. We also discussed about mining and transaction. So, if anyone of
Hey, yeah, hi guys. I know, I think there was some uh, voice issues, right? Audio issues. So yeah, welcome back to the today's session, right? And probably like you can post your doubts, queries, right, in the comment section. I think we'll just give another 5 minutes so that people also can join, and then we'll able to answer all the queries, right? And then we'll be starting with our today's session, which will be again around some of the concept on Tezos blockchain, and then we'll be covering some parts of hands-on session, right, where you'll be deploying a smart contract using some of the tools that we have developed, right, for the community.
Yeah, so if you guys have any questions, shoot it now. You can ask right now if you wanted to ask anything yesterday or if something is not clear, and then we are ready to go with the today's session. Yeah, and let us know if you guys can hear us clearly. No questions?
I think there is generally a delay of a minute or so between, I think, once like we complete, right, whatever we are speaking, and the it gets like transmitted for the live audience, right?
Okay, okay.
Yeah, so generally, like yesterday, I was observing that, like once we ask question, right, generally after 1 or 2 minutes, question starts popping up. How is the privacy of user maintained on a blockchain? Yeah, probably whom you want to like take that question.
How the privacy of users maintained on the blockchain. So there can be multiple ways using the privacy of the blockchain. Initially, depends on the design of your smart contract. Let's say if you are putting your name, age, your account number, and stuff like that on a smart contract, then if you even if, first thing, that's not the good practice to put all of those things, because usually uh, smart contracts have a very specific use case, which can be no. So blockchain comes in the picture where you want some sort of transparency. Let's say if you want to show some transactions and you want to show, maintain the transparency in the system. But if you want to store any information that is private, you can always encrypt it and then store it. There are many concepts of encryption in the blockchain. So you can basically just encrypt all the information you can store. And then there is also concept of zero knowledge proof. So that is something that that's an interesting concept to explore. So maybe in the next, as we talked about protocol upgrade or self amendment yesterday, in the next update of Tezos, there will be a feature where you could encrypt all of the information using zero knowledge proof on the smart contract. So that way you can always maintain your privacy. Many ways around it. It depends upon the architecture, how you build your application or how you write the smart contracts. But yeah, as it doesn't have a central authority or central server, maintaining the data, so it is up to hand control of the user if he wants to delete the data, or if he wants to keep the data, or if he wants to encrypt the data, or if he wants to make the data public. Again, that depends upon how a smart contract is designed. So I hope that answers the questions. Anything else?
So yeah, I think we'll probably get started, right? I'll just give you a summary or recap, right? What we did yesterday. Correct. So I think all of us got to know, right, how let's say a transaction happens on a blockchain, right? What exactly happens when you do a transaction, right? It gets to a node, right? Then it gets picked up by the any miner, right? Who feels that okay, the transaction fee is like high enough that I should include this transaction in a block, right? Because that's the kind of motivation for any miner or baker in blockchain, right? The reward that they get from the transaction, right? So that's how it gets prioritized, right? So the more fee you are willing to pay, right, the faster your transaction happens on any blockchain, right? Because it's again incentivize the whole process of mining or baking, right? That's the whole point. Okay. So yeah, I think, and then we learned about okay, what is proof of work, right? And then we briefly talked about proof of stake, right? And liquid proof of stake. We'll be going in little bit detail today about both of them, right? And then we'll talk something about, let's say, wallets and keys, right? And there we'll be ending whatever our knowledge base, and then we'll just jump right into writing some smart contracts. So yeah, that's the agenda for the day today. So let's get started. Okay, so as we talked yesterday, right, we talked about multiple features of Tezos blockchain, right, how it differs from any other blockchain, right? So the major thing is the self amendment, right, and on chain governance, that you don't have to do hard forks. Everything happens on the chain, right, without leaving the chain. Even all the testing of any new upgrade, right, that also happens on the same chain, right? So you don't have to go anywhere to do all those things. Correct. And once everybody approves that okay, yeah, this update is valid, right, all the nodes automatically updates themselves. So basically it's kind of a self amending software piece of software, right? And that is not that very common, right, in the correct in the current world. So yeah, that's why kind of Tezos differs from any other blockchain, right? Because when you are running thousand of nodes, right, across the world, it's very difficult to bring the whole community together on a single forum, right, and then convince everybody to kind of for the upgrade, right, or present your idea and then showcase whatever the update, right? So that's where the this self amendment feature comes handy, right? Everything happens on the chain, and all the miners or bakers, right, they can verify what's the proposed update and how it is going to affect them, or how it is going to be performed, right? And then once they accept, once we have a quorum, right, it will be accepted after the testing period, right? And then your chain will be updated to the latest protocol. We already have done three upgrades, right, so far, starting with Athens, then Babylon Net, and recent one was Karthad Net, right? Correct. So yeah, then we even talked about smart contracts, right? The language that we write the contract in the Tezos is a Michelson. Michelson is again a functional programming language, right? The Tezos blockchain has been written in I think OCaml. Yeah, not I think. Sorry. Yeah, so I got confused. It's written in OCaml, and yeah, it's a like functional programming language, and that allows the whole thing to be like kind of formal verification, right? So any smart contract that you write on a Tezos blockchain, you kind of mathematically verify and prove that the functions, right, or whatever logic that you have written, it does exactly the same thing, and then there are no vulnerabilities, right? So that's the main advantage of let's say Michelson or formal verification, right? I think Tezos is the first blockchain, right, which supports this kind of a formal verification. And then it has a very rich set of data types as well, right? It supports almost all of our real world data types, right? So that is also very like a little uncommon to see in smart contracts, right? To have features for, let's say, complex data structures, right? And again, yeah, this was the other feature that we talked, right? That why your smart contract could be hacked, right? Because you write a smart contract in a language and then it gets compiled into another language, but then that language you can't read or do anything on that, right? So here is the bytecode. So in bytecode you can't like kind of taste or do anything, right? So that's where your Michelson comes into picture. Our community, right? So they have developed a different framework for the Michelson, different languages, right? Which kind of transpiles code into Michelson code, right? So it could be Python, it could be JavaScript, but at the end of day you get code in Michelson, and then this code is can be formally verified. So that's the another main advantage of let's say Tezos blockchain, right, over other chains. Then let's talk about proof of stake, right? So as we had discussed yesterday, right, proof of work is like you do some piece of a computation, right, using your CPU and all, and then you attach that nonce to the block, right, as some kind of a receipt of the work that you have done. And if that gets accepted, right, if you are the first guy to produce that proof or receipt, right, you get rewarded with the some amount of, let's say, native tokens, right? So in case of Bitcoin blockchain, you get rewarded with bitcoins, right? Also you get fees from all the transactions included in that particular block. While in proof of stake, what happens is, instead of, let's say, attaching a receipt for the work or computation that you have done, right, you get your right to mine or bake a block, right, using the amount of the stake that you have in the network. So when we call about stake, right, it's basically, in most of the cases, it's the number of tokens that you hold in your account, right? Based on that, you get a chance to like bake or mine a block. Correct. But then again, this chance is, it's not like the person, right, who has most number of the coins, only he will get the chance to bake a block. No, it is not like that. It will be always in terms of probability distribution, right? So everybody will have equal probability distribution. It's just that the chance of a person who has a higher balance, right, so the chance of person of getting a right to bake a block will be higher than the guy who has a lesser balance, right? But on the overall, right, all of them will have equal probability of getting a chance to bake a block. So that's how proof of stake works, right? And then but Tezos, so Tezos has a different concept for a proof of stake, right? It's a more kind of a liquid proof of stake, right? So how basically that differs from, let's say, your normal proof of stake, right? So we do have a comparison, right? We have delegated proof of stake in EOS, Lisk, Tron, right, everywhere. But generally what happen in depots is your validators, right, or your miners are kind of predefined, or they are kind of very limited people, or let's say the number of coins that you have to have, right, to be a miner, it's very high. And selecting, let's say, that a miner, right, that also people or any miner, right, that has to go through some process, right? While in Tezos, what happens is, if you own, let's say, minimum number of tokens, right, that requires by the platform, right, then you can start your node right away, right? So let's say the minimum number of tokens that you have, right, it's kind of for 10,000 thesis, right? So which is pretty low than the other blockchains, right? Yeah. And so don't just look at the number, right? Just look at the total overall amount as well, right? So it is pretty low, right? And then the return also which it gives, right, it put like approximately, right, it gives around 7 to 10%, right, overall. Yeah, so that also is very good than other proof of stake blockchains, right? So that's another point. And then what happens is, like, let's say if you don't have 10,000 coins, right? So in other blockchain, what happens is you can't basically make a block, right, or get rewarded for the tokens that you are holding, right? But here what you can do is you kind of even if you have, let's say, 10 tokens, right, you kind of delegate it to somebody else. And when I say delegate, right, it's not like you'll be handing over your tokens to them. It's just like you are giving rights of that token, right? So the way parliament works, right, we delegate our right to do something, right, take decision to our MP or MLA, right, when voting happens. Similar thing here happens, that you delegate your right to vote on behalf of you to the baker in the network, right? So that's how it happens, and then the baker will share his rewards with you based on the number of tokens that you have delegated to him. Correct. And then validators, right? So as I talked, the number of miners could be dynamic, right? There is no fix that okay, you need like only 50 validators, only 100 validators. It's not like that. Anybody can become a validator on the network, right? And that's make Tezos a truly decentralized network, right? So that's about probably liquid proof of stake. We can talk about that towards the end of the session, right? If time permits, more about that. Correct. Let me just check if we have questions. Yeah, so keep posting questions, right? Whenever you guys have any questions. Correct. So as we had talked, right, in Tezos, a cycle is kind of the way we measure time, right? We can't just do by timestamps, right? So how we measure time in a Tezos blockchain is a cycle. A cycle consists of 4096 blocks, right? And I think the time between each block is 1 minute, right? So generally, a cycle takes anywhere about, I think, 3 days to complete, right? Almost 3 days. So yeah, that's what its cycle is. And then these are some more details of liquid proof of stake, but I don't want to confuse you with that, right? As of now, we'll just keep it to the smart contract side of the whole thing. Correct. Yeah, cool. So yeah, let's get started with the development part, right? So before jumping into development, right, I just want to like discuss one more concept, right, which is a private key and public key. So does anybody have any idea regarding, let's say, what is private key or what is public key? Please feel free to post your comments, right? Why we use private key, why we use public key, right? Anybody has any idea on what is symmetric encryption or asymmetric encryption, right? Because this is very basic concept of any blockchain, right? No matter what blockchain you will be working, right? This will be very important piece that you will have to work during your stint at with any blockchain. Yeah, I think I like this question. How will we get certificate? So is it your normal certificate or you are talking about a blockchain? But he's, I think, to the point. He's asking about, yeah. Okay. Yeah, public means accessible to all. Yes, that is correct. But then overall, right, what is the concept? Right, we have public key, we have private key associated with it. We have private key, we have public key associated to that private key, right? And how do we use? Public key is accessible to all and private key is only with you. Yes, that is 100% correct. And private means accessible to only the owner. Yes, yes, correct, correct. Yeah, public key used as a account address. Yes, definitely. Okay, I think Rajan, your question will be answered by, I think, one of the organizer, right? How you get your certificate? I think if you are talking about the participation certificate, otherwise, I think you'll have to be more elaborate on what exactly you mean by certificate, right? Yeah, public key is used to encrypt, private key is used to decrypt. Perfect. Yeah, so let's talk a little bit about the encryptions, right? So in blockchain, to make sure that everything is secure, right, we use lots of cryptography algorithm. Right. So how do we identify a user on a blockchain, right? Because I can't give my, let's say, I can't use my bank account or user ID password, right, to log into a blockchain. It doesn't work that way. So on a blockchain, how it works is you will always have a set of a private key and a public key, right? So this is called asymmetric encryption basically. With this, you control your identity or your account or your wallet, right, on the blockchain. Now there are different ways to generate this wallet, right, that will cover later. But any wallet that you use on any blockchain, right, will always end up with one public key and one private key. Okay, so let's talk about first symmetric encryption, right? Okay, so before going to that, why do we need, let's say, all this kind of a private key and public key, right? So it's to basically make our communication, right, secure, right, and plus to make sure that to identify who has done the transaction, right, or who has signed the transaction, because we need that as well. Whenever we do any transaction, we need a proof that, yeah, is it coming from the right person or the wrong person, correct? Then only we can use. So how we can do that? So let's talk about symmetric encryption. Let's say if I want to send some money, right, to let's say Prajwal, right, on the network. So I just can't directly send any information. When I say money, let's say if I'm sending some information, right, which is very crucial, so I can't just send that information directly in a plain text, right? Because if I do that on the network, anybody can just sniff the traffic, right, and they'll get the information about what is it about, right? Then it's no longer secure. So what I can do is I and Prajwal can be in some kind of a mutual agreement, right? That, see, I will kind of hash all the information, right, using this particular algorithm, or in this particular manner, right? That, let's say, if it is ABCD EFG, right, till Z, what I can do is I can always do some kind of a numeric encoding, right, 1 2 3 4 5 to up to 26 later, right? And then I can have some kind of a logic to treat how to, let's say, identify between 2 and 20, right, from encoding. So all those things I can do. But so that is basically a symmetric encryption, that I tell the other person, right, that this is how I'm going to encrypt the data, so he knows that how to decrypt the data, correct? But the risk here is that let's say when we are doing this kind of exchange, right, that will happen over a public channel, and if somebody sniffs that, right, then they'll be able to crack all of our traffic, right? So let me just quickly share a image, right, which kind of displays let's say symmetric encryption. Yeah, I hope you guys are able to see this. Yeah. Okay, so this is symmetric encryption. Okay, what happens is, let's say a guy on the left, right, he wants to send some text to on right side, right? So everybody will be using the same key. So first we go and transfer the key to the other end, right? Then we encrypt the data with the same key. The guy will decrypt the data with the same key. But when we are passing this key, right, so it could be on a public network we can pass, or I can just give a pen drive, right, when we physically meet, right, or I can just email him the secret key. But then there is always a chance that it gets exposed, right? So that's why we use asymmetric encryption, right? There what happens is uh, there will be two set of keys, right? Each person will have their own private key and a public key, right? So what happens is, whenever I want to send the data, right, from, let's say, person on the left to person on the right, what I will do is I will kind of I will always have the public key. That is why it is called public key. So you can kind of compare this public key and private key to, let's say, your home, right? So your home address is a public, you give it to everybody, right? So that is your kind of a public key. But the key to your main door, right, in your home, that you don't give it to anybody. So that is something of your kind of secret key, right? So by your home address anybody will be able to identify, but you, only you will be able to open your home, right? So it is something like that, that with your public key, right, anybody will be able to send a message to you, but only with your private key you will be able to decrypt that message. So here what happens is, let's say person on the left is want to send some data to person on the right. So what he does is, whatever data that he wants to send, right, he will encrypt that data using public key of other person, right, other guy, because public key is public. So he can use that public key and he will encrypt the data. Now this data could be decrypted only by the person who has the related secret key or a private key. Correct. So this message can go to 10,000 of people, but the only person who has a corresponding secret key or a private key, right, only he will be able to decrypt that message, right? So I hope, I think everybody has understood this, right? I'll wait for some questions, right, because this is very important concept in about like what we are going to do, right, or what we'll be doing as a blockchain developer, right? This is very like important concept, right? So I'll be waiting for yeah, okay, can you zoom it? Yeah, okay, just give me a moment. I think I'll share again and I'll zoom. Yeah, please feel free to ask any questions, right? Let me know if you guys want me to explain it again, right? I think some of you may not have seen everything because I was in a different window and I didn't see the message of zooming in, right? Hey Rajan, I think the organizers will get in touch with you, right, for the participation certificate. Okay, what is ciphertext? Ciphertext is encrypted text. It's encrypted text. So whenever, let's say, you encrypt some data with somebody's public key, right? So whatever the result, right, it's called like basically encrypted text or ciphertext, right? Uh, yeah. And other thing is, so it's nothing but a hash of something, right? So yesterday we were talking, right, I showed you one set of text and I told you that once we put it through some kind of a hashing algorithm, it will generate some random text, right, some kind of address, right? So ciphertext will look something similar, right? It will be some kind of a hash with some numbers and all, right, jumbled up. So once you yeah, so that's, I think it's all about, it's basically a signed data or something like that. Yeah, cool. So I think yeah, I don't see any other questions, right? So let's get started with the development part, right? So to get started on Tezos blockchain, right, all you have to do is you have to go to, let's say, uh, developer.tezos.com, right? I'll be just posting a link in a while, right, in the chatter. I'll ask somebody from the admins, right, to post this link. I'm pasting it here. Yeah. You just go to this portal, right? You would be seeing something of this sort. I'm not sure why it has not started yet. Yeah, okay, I think it is sharing. Okay, till now I think, let me, okay, does public key has some security related to it, like the one Google give for its API? Yes. Basically, public key has so in this blockchain world, right? Public key inherently they don't have any security, right? In blockchain world, you have to like control your keys, right? So you have to make sure that your secret key or private key, right? You secure it, right? Because not your key, not your coins. That's kind of a proverb in a blockchain world now, right? If you lose your key, right, you can't claim. So let's say, to again give you the same example of home, right? If you don't have, if you lose your key to home, right, the person whoever has the key gets access to your house, right? So I'm not talking about, let's say, property paper and court system and everything, right? The whole legal drama, let's forget that about, right? But let's say you live in a world when you open your house with your key, right? So if you lose your key, and the guy whoever has the key, right, he'll kind of have access to your house and he'll control. So yeah, with great power comes great responsibility, right? In blockchain, you basically take control of your data, right, your money in your hand. So then you'll have to be more secure about that. But there's nothing to worry about that. Why? Because there are people, right, in our community, they are working towards this, right? They are bringing security to your smartphone, right? You can unlock your wallet and everything through your smartphone. And then we have a hardware wallets, right? So which comes like, it looks, if you just go and search, right, Ledger Nano, right? So it looks like a pen drive, right? But it's a hardware wallet. And once you keep it secure, right, nobody will be able to kind of access that data. It stays offline, right? So the chances of like somebody stealing your data or keys, right, would be very less. Then we have cold wallets, right? So those are again similar to this kind of a hardware wallet only, right? You can compare it basically. Then people are working on let's say a kind of wallet solutions, right? Where you have your credit card kind of a card, and only you can kind of unlock that using probably some biometric or something like that, right? So yes, but people are working towards that. So that's how you have to keep it secure, your keys. But then there's nothing wrong in giving public keys to anyone, right? Because that's where your encryption algorithm comes into picture. You can generate a public key from a private key, but you can't generate a private key from public key. It's only one way street. Okay, how does private key and public key generates? Yes, very nice question. Good that you asked, right? Generally, how we do generate a private key is, we give some random text, right, to some kind of algorithm, and it generates a private key for us. And public key is just a hash of a private key. So that hash could be different algorithm, right? So the normal hashing algorithm, if you would have heard, right, it's, let's say, mode 256, right, show 256, or let's say mode 9 or anyone, right? So those kind of hashing algorithm are there. So then we have base 64, right, base 58, base 54, right? It could be base 24 as well, not 24 but 52, right, where you have letters from A to Z, small a to Z caps. So all this kind of a different hashing algorithm you can use to create a public key from your private key. I'll show how a set of random words generates your private key, right? I'll demo that as well. But as of now, you can assume that there will be some kind of a black box, right, which will give you some random set of words. Those are called mnemonics, right, mnemonics, and then there will be associated private key generated from those words. So even if you change the order of the word, right, out of those, let's say 12 words, then also your private key changes. So you have to keep secure those 12 words, right, and then if you lose those 12 words, or even if you forget their order, you lose your private key. So we'll I'll show you the demo at that time. Probably we can talk more about that. Right, 256 words key used earlier now. Okay. Okay, got it. Yeah. So whatever I think Prajwal is telling, right, I think he's talking about the web encryption, right, that we use for HTTPS, right? But yeah, this whatever we do in blockchain is pretty similar to that. There's nothing, no changes, right? Exactly. So in blockchain world, private key will be generated by blockchain only, right? All blockchains run on particular hash cryptographic algorithm, right? So that algorithm only will generate this set of keys for you. These keys are called as a wallet. So if you have heard about wallet, right? Probably if you are familiar with Ethereum, you may have heard of Mu, right? My Ether wallet. So there, when you go and generate a key, a wallet, right, it basically generates a secret key and a public key. So those are getting generated from let's say some kind of a cryptographic algorithm, right, which Ethereum uses. So all blockchain, it will be similar, right? Yes, exactly. I think Prajwal has explained it very well, right? Okay. Cool. So talking about the development, right? Developer.tezos.com. Here is the place, right? You will find all the resources to start your development journey or wherever you get stuck, right? So we have all the basic stuff, right? Like, okay, how a node works, right? How to deploy a smart contract or run a sandbox node, right? Sandbox node is nothing but you run node on your local machine, right? So that is sandbox node or a local node. And then how to, let's say, kind of build or manage the Tezos environment, right? So those are the basic steps. Then for any blockchain developer, right, generally you don't have to know much about the other things, right, how encryption works and all those things in detail, but it's always good to have a knowledge about that, right? Because yeah, it's a part of your day-to-day job as well, right? It will affect you, so you have to have knowledge about that, that how something is working. The main part is for any blockchain development, right, it's a smart contract. That's why we are here, right? So in Tezos, you can write smart contract in different languages, right? For Pascal and OCaml languages, right, you can use Lego, which is a smart contract language. Then for Python, we have a SmartPy. For Haskell, we have Moriarty and Lawrence, right? Morley, okay. Yeah. And then domain specific, right? So then we have a archetype, right? So it's again, see, all these languages are developed by our community only. So based on their expertise, right, somebody would have come up and said that, okay, yeah, I think that if I write some kind of a library, right, or a language which allows a user to write a code in this one of this language and compiles it to, let's say, Michelson, right, then it will be useful. So you also can tomorrow come and say that, okay, I want to do it for let's say Java, right? So then you should have some plan that, okay, how will you compile a Java code into Michelson code, right? And then you can present that to Tezos Foundation, right? And you can get a grant to develop that kind of a language, right? So there is a, like, the sky is the limit basically. You can write smart contract in any language, right? Then we have different libraries, right? So all these libraries are useful when we, let's say, want to integrate our code, right, into front end, right? So we have a Conceal.js, Conceal.py, right? So Conceal.js is, as name suggests, right, it's a JavaScript library. You can use it with your JavaScript frameworks, right? It could be React, it could be Angular, it could be plain simple HTML, CSS, right? So there you can use JavaScript library. Similarly, we have a Conceal.py, that is Conceal.py, right, for Python language. Then we have EasyTZ, which is again a JavaScript based this one language, PyTezos. Then we have different wallets, right? Tezbridge, then airgap, right? Airgap coin library. So what it does is it allows you to kind of sign transactions and unlock wallet, right, using airgoin's airgap's wallet, which is a mobile wallet. So yeah, we have .NET libraries as well, right? So when I started, right, this list was, I think, limited to only 5 languages. So within a year, people have come up with the rest of the items, right? So now we have approximately more than like 10 or close to 15 items, right? So yeah, that's how quick the whole ecosystem is evolving, right? Then the part comes, right, that how do I kind of see all these things, right? How do I know that the transaction has been done, or how do I know that what account has what kind of a balance and all those things, right? So we have a blockchain explorer, right? Aeronex, Tezos ID, Better Call Dave, Tezblock, TZ States, TezKT, all those are like kind of a different explorer, right, for different purpose. Some of the explorers are useful for smart contract data, right? So Better Call Dave, right, and I think Aeronex, right? So those are smart contract friendly. So then thesis states, right? So that is again transaction specific. So let me just go to one of the blockchain explorer, right? I'll be just quickly sharing that tab with you. So see, this is how any blockchain explorer looks like, right? This is on Carthage.net. I can just take a look at any account, right? So as I told you, right, if you can look in this top bar, that is the public key address, TZ1. All the public accounts, right, or all the wallets or public keys on the Tezos, right? Either it will start with TZ1 or KT1. TZ1 is the address for any wallet, KT1 is the address for any smart contract. You can identify by that, right? And then once I go to Explorer, let me zoom it little bit, right? It will show all the data, like, okay, what balance it has, when was the last time it was active, right? Then how much balance it can spend, whether the account is revealed or not. So revealing an account is like letting everybody know that, okay, this account is kind of active and anybody can send data to or balance to this account, right? Then as this is a kind of a baker account, right, it has, I think, other information as well. It shows how many transaction it has done, right, or how many smart contract it has deployed using this account. So that's where all the blockchain explorers comes into picture. Yeah, okay. So going back to again our Tezos developer page, right? Yeah, so the below section, right, we have all the resources. Let's say if you want to go and write a code for Tezos node itself, right, or you want to push any upgrade, then you have enough resources to get started on that. And then how to run your bakery, right, or a personal node, everything you can find here. Then we have different tools like let's say this was IntelliJ plugin, right? Michelson plugin for IntelliJ. If you are familiar with IntelliJ plugins, right? IntelliSense basically. So we have that Michelson plugin. Then Emacs mode we have. Then Taster, right? So again, this is one of the tool which was developed by us, right? By Tezos India team, right? This tool is to kind of it allows uh, all kind of a smart contract development, right? Through we have different bundles also under the Taster, right? So we have a CLI tool which allows everything, right? Getting the balance, deploying a smart contract, calling a smart contract, creating a wallet, all those things through command lines. Then we have a GUI version of the same that we'll be going to use today. So that also has the similar functionality, right? And then we have bundles. So we already have published the React bundle, which is kind of a ready-made boilerplate to get started with the React DApp. right? So there you can build your smart contract, then it already has functions to kind of call your smart contracts through your React app, right? So all that, all the code and the links, right, I'll be sharing with you guys soon. But yeah, so all the resources, right, are there on the Tezos developer site. So you can always use these tools. You can reach out to the community members, right, through their different chat platforms, right, if you get stuck. And you are always welcome at Tezos India Telegram group, right? We are very active and everybody is very helpful and responsive. So yeah, that's all about, let's say, getting started on your blockchain developer journey, right? Okay, so to, let's say, do any smart contract development, right? Today, if you guys are familiar with Python, right, we'll be using SmartPy, right? Uh, which is again a Python-based smart contract language, which in which you can write code in Python-like language, but it gets compiled to Michelson. So I'll share SmartPy ID. I hope everybody is able to see the screen. Not sure. Yeah, yeah. So again, I'll be posting this link as well in our chatter. This is the place, right? You can write a smart contract in Michelson language. I think this should be pretty fine, right, to see. If you have any issues, right, regarding the fonts or anything, just let me know in the comments. So here I'll just give a walkthrough over all the menus and different functionalities, right? So here is the main editor where you write your code. In a while, right, we'll be jumping on that, or how to write a code, right? Till then, let me just give you a walkthrough of whole setup. Here it will show you different templates, right? Uh, so we already have, let's say, some of the ready-made templates for different kind of a smart contract, right? So as you can see here, we have a normal, a very simple welcome type of code, right? It's some kind of a very basic calculator, right? Then different type of data types, right? It supports, as I had told you, right, Michelson supports a rich set of data types. So similarly here also, most of the Python data types are supported here. So all the different data types, right, we have a smart codes already written for that. So if you want to refer to them, right, you can do that probably, right? So yeah, that's all about the different, you can just go through it, right, whenever you have a time after once this is over, right? See, we have a smart contract which uses hash functions, right? How do we use this? So as Om was telling earlier, right, in the beginning of the session, that we can't store public information on the blockchain, right? So at that time, what we have to do is we have to use some kind of a hashing function to store those information, right? So you can store some critical information on the blockchain, but you have to then use some kind of a hashing algorithm to make sure that it's not revealed to public, right? So you can again all those use all this kind of algorithm also in your smart contracts. Then let's say if you want any help, right, regarding any data type or anything, you just have to click on the open reference manual, right? It will open a new tab, right? Let me just go through, take you to, through that reference manual. Oh, okay. Yeah, I know, like fonts are not visible, right? But again, it's just for a reference purpose, right? It's a digital share, so I think fonts should be visible, because I see it pretty clear in the sharing window. But I'll zoom in, right? The other issue is once I zoom in, right, the information that we see, right, it reduces. So that's why I like kind of stay away from zooming in. But yeah. So this is a reference manual, right? It has, as you can see on the left hand side, right, uh, it has uh, it has covered everything, almost everything, like what kind of a different expressions or commands or entry points or contract you can use it in a while building a smart contract, right? So those are very basic building blocks of any smart contract. You can have expression, you can have commands, you can have entry points. I'll be talking about that later, right? Then we have different data types as well: boolean, bytes, right, lambdas, keys. So all these are different concepts that you will be needing for sure when you write some kind of a complex smart contract, right? Okay, so yeah, that's about the reference manual. Again, let's switch back to our IDE. Yes, Tezos smart contract only support Michelson. Michelson is the base language of Tezos blockchain, right? So just a minute, just a minute. Yeah. So as I was talking, right? Guys, just a minute. Hey, yeah, guys, sorry about that. That was my niece. She wanted to join the blockchain session, right? But I just told that she's too young to join that. So sorry about that. Yeah. So, okay, coming back to the ID part, right? So this is how any smart contract, right? In a smart pi, it looks like. I believe I was answering somebody's question. Yeah. Does Tezos smart contract support only Michelson? Yes, Tezos smart contract, the Michelson is a base language. It supports different language frameworks, right? Like smart pi or Lego, right? That we have seen. So you can write the smart contract in that language, and those gets compiled to Michelson. But at the end, all the code will go in Michelson only and not any other language. For your reference, people are working on some kind of a language or a transpiler, right, which kind of converts your uh, solidity code into Michelson code. So yeah, if you are coming from Ethereum world, it will be a lot easier for you, right, once those kind of package or tools, right, are released. So let's talk about writing a smart contract. So this is a very similar, like simple Python code, right? So as any Python class, right, we have a simple class called hello world. The init part, right, that you see here. Let me zoom in little bit. I think probably for the people. Let me know if you're not able to see, right? Please let me know in comments. So as you can see, right, you just have to first worry about only the selected part of the code, right? Forget about the test section. In a while, I'll explain why it is required, right? So to write a smart contract, it's very simple. You just define a class, right? You import that whatever package, right? Smart pi in this case. Then you have to write some kind of a init function. So init is nothing but your constructor for your class, where you can pass some arguments for to initialize your variables in a smart contract. So think it of it as like whenever you are deploying your smart contract on the network, right, you want some data to be stored on that smart contract. So all those data you can pass it through init, and then it will set your all the data, right? Then when we want to call this smart contract, right, because let's say we want to alter all these variable, right? As of now we are just storing name, but then let's say if we're writing a smart contract for election, right, so then we have to store a list of candidates. Then we have to store a list of votes, right, that which guy got how many votes, right, when election closes. So we'll have all those kind of variables in our private class, and to alter that we need some kind of a way to kind of let's say alter those variables, right, like let's say add votes, right, or close election type of thing. So that's where these entry points comes into picture. Here what we are doing is we are changing the name, right, through this change name entry points. So change name entry point takes this new name, and then whatever new name that has been passed, right, while calling this smart contract, we change our local data to that. Now for each of these operation, right, it will create a simple transaction on a blockchain. How? I'll be just showing you in a while. Correct. So once you, let's say, write this kind of a simple smart contract, right, all you have to do is uh, but yeah, so before jumping to that, we have to write some test cases. So test cases are a way to kind of test the smart contract that you have written. Why it is required? Because in blockchain, how you can test your smart contract is like you have to continuously deploy it, right? So for any changes that you do, you have to deploy it. Now, if you have some syntax error or something, right, your transaction will fail. So that debugging process, right, it is very time consuming. So all thanks to SmartPy, right, our community members, right, they have come up with this ID. So if you have any errors, right, in your code or anything, you can just detect it here at the time of writing the smart contract, and then you can test all the functions, right? So once you are writing, once you are done writing with let's say your smart contract part, right, and then test, right, again writing test is very simple. All you have to do is uh, initialize your class, right? So here I'm initializing hello world class with some string. So as of now my value of my variable name will be hello world. Then what I'm doing is I forget about the next statement, right? Then the third statement at line 17, what I'm doing is I am calling change name on that instance. My instance name is C1. So on C1, I'm calling change name with Bob. So now my data should, the name, right, it should be Bob. Correct. Scenario is nothing but some kind of wrapper to show all this data in a beautiful manner. What is that beautiful manner? In few seconds, you will know. So once you are done this kind of code, right, all you have to do is just have to click on run. I'm zooming out little bit, right? So as you can see here, it shows all the values, right? So storage is nothing but the data that you are storing in your smart contract. So as of now, our smart contract stores only name. So it is showing hello world. So when we execute this first line right here, C1 is equal to hello world, and then we do scenario plus or equal to C1, it kind of prints your smart contract here, this line 16 number, right, it prints your smart contract. Line 15, right, it prints any changes in your storage. So storage and balance, right? So as of now we are not sending any balance, so balance is 0. And then as we are sending hello world string, right, it shows that hello world will be stored in a blockchain. Till now it's not been stored. It just kind of simulates that once I deploy the contract, what kind of changes will be there on the blockchain itself, right? So far we haven't deployed that on a blockchain. So let's say when I again call this function, right, c1 dot change name, to change the data that I have stored on the blockchain. See here it shows that name got changed to Bob. Right, zoomed it a little bit. So what I want you to do is I'll just leave this screen here for a while, right? I'll just give probably 5 minutes. You can go to this link smartpy.io/dev, right, that we had posted for your reference. I'll just post it one more time. You just write this piece of code there, right? You can directly like copy it line by line, and then just click on a run, right, and then let me know if you face any issues, right, or if you are able to run also, just let me know in the comments. right? I will zoom a little bit. Make sure it is a Python, so it is a indent sensitive language, right? So please make sure that you kind of indenting it properly. Once we do this, I'll show you probably how we can deploy this smart contract on a live blockchain. Okay, for your reference, I'll be just sharing a link, paste bin link in the comments, right? So you can just probably copy code from there also. But I would recommend that you write the code. Why? Because then you'll get a feel of it, right? That you'll get some errors and all those things. So, but yeah, you can copy paste this code and just press on a green button, right? And you'll see the similar result in your this one console. Just comment done once you are able to run the code, right? So I would know and we'll proceed further. Cool, yeah, nice, Rishabh. You can just go over through different tabs that you see right on your right hand side: contract, smart pi, storage types, all Mickelson, right? To just see and just in for whatever you can. I'll be just explaining in a while, right? Till like once like some more people would be able to execute the code. Cool. I think Aniket is also done. Sometimes it may take some time initially to load the smartpi.io/dev, right? But once it's loaded, I think it works pretty smooth. Cool. Okay, Booksmate is also done. So yeah, let's. So I'll just explain you. Okay, yeah, sir. What is SP entry point, right? SP entry point is a telling compiler, right, that this is the function that we will be calling from the outside. So if it is a simple smart contract, simple Python language class, right, we can't convert it to Michelson, right? So that's where all these marks comes into picture: SP entry point, SP contract, right? All those are part of a package called SmartPy, and it tells the compiler that this is how you have to compile the code, right? So yes, exactly, I think Harsh has given in more technical terms, which is a decorator, right? I didn't want to go there, but yes, it's a decorator function, if you are aware about design patterns, right? Okay, so when we, let's say, if you go to storage, right? So storage is nothing like, it just shows what all the data or types that you have on the smart contracts, right? See, it shows that it is of type sp.tstring, right? All these are Michelson type, basically equivalent of Michelson type. Okay, when I go to Michelson tab, which I think all of you would be able to go, I am just zooming out little bit because that's necessary here. So you can see that storage is the initial storage, right? So this we have to pass when we deploy a contract. So these are the kind of initial value that we pass to constructor. So it will be in a different format for a complex smart contract, right? As I had told you, right, it's a functional contract language, right? So whenever a complex storage will be there, right, with multiple variables, it will be some kind of a structure where you will see left, right, right, left, kind of a structure, right? Just let me load some complex smart contract, right? And then I will be able to show you. Load contract script. Let's see if I'm loading this election smart contract, right? This is the contract to kind of do a election on a blockchain, right? When I run this, okay, this is the old one. I think it's migrating. Oh, okay. I think I may have to change it. So I'll just take some of the ready-made load regular template, world calculator, right? Yeah, you can see, right, if the contract is complex, the storage also will look something of this sort. Just zoom in little bit. Yeah. So again, this is how you basically provide your arguments in a functional programming language, but you don't have to worry much about that. You have got SmartPy, right? So it will take care of you. Let me load the our existing template, which is a hello world. Okay. Okay, so if I go to Michelson tab, see, if you click on code, right, it will show you the Michelson code. See, this is how your code in a that you have written in a SmartPy, right, gets compiled to a Michelson code. I know it looks pretty dangerous at this point, but once you write more smart contracts, you'll be able to make sense of this code, right? All these are kind of a variable, not variables, but kind of a symbols in Michelson language, right? So each of this symbol has some meaning, right? So that's how the whole thing happens. It's a stack based language, so it kind of creates a stack for each of the operations, right? So I won't go into much detail for that, but again, yeah, you can do it same thing in JSON as well, right? So it generates some kind of a JSON for the same code, right? This is more readable than the pure Michelson code. So yeah, once, let's say, we have written our code, right, now the next thing is to deploy it on a blockchain, right, running blockchain. So there are always two options, right? Either you can run a you can kind of deploy a smart contract to a running blockchain. So Tezos has one mainnet. So to do anything on a mainnet, you would require some real Tezos, right? And Tezos is priced at I think $1.5, right, per token. So if you don't want to spend that, then you can do all those things on a testnet, right? Which is anyway the first option that all the developers do, right? So there are different nodes for this testnet, right? So the testnet that we use as of now is a Carthage net. All the open source, let's say all the community members, right, different like Conceal.js or Tester, right, which is again this is India Foundation's tool set. So we run our own nodes. So you can kind of go and deploy smart contract on that, or you can run the whole blockchain, right, on your machine itself, and then you can do that. So to deploy any smart contract, right, first thing you'll have to have is some kind of a wallet. So wallet is nothing but private key and a public key. How do you get a wallet? You just go to faucet.tzalpha.net. You can find this link from Tezos development page. Let me just share that tab and take you there. You can go here. There's a faucet. Yeah, so you can go and click on testnet faucet right here. It will open a new tab. Right from there, there is one more link. I think I'll just give you direct link to faucet. That would be more simpler. Let me just copy and paste it to the chat. This is the link I have shared. I'll be sharing the screen for the same thing. Right, you can go here. It will just give you some kind of a dummy account. Once you click on this, right, get testnet, it will download a JSON file for you. Okay, so I think it has downloaded a JSON file for you, which looks like this. Right now, how do we let's say kind of uh, get, or this is just the JSON configuration, right? You have to go and activate that account. If you see here, right, you will see a PKH. So if we go to our blockchain explorer and enter this account's PKH, you won't find anything. Why? Because this account has not been activated on the blockchain yet. So how do we activate this account, right? So there are multiple ways. You can do it programmatically. You can use some tools, right? So what we have done is we have developed a tool called Tester GUI, right? Again, I'll be just publishing, let's say, link for this tool, right, on a private chat with you guys. You can download this tool from here, right? I'll just run that tool for you. Right, let me just run that tool. I have downloaded in my local. Once you download and then run the tool, right, it will look something of this sort. It has a GUI version of it as well, which is a sorry, CLI version of it, which is called Tester CLI. I'll be posting link for that as well. Okay, repeat from faucet link code, right? So once you go to faucet, you should be getting, you just go to faucet link, you do the get testnet, right? So it will give you a JSON. Now that JSON is not been activated yet. It's just the config, but if you take the PKH from the JSON and you go to any blockchain explorer and find out, right, that whether that account is there or not, you will find that, yeah, the account is not there. And again, this faucet account will give you an account for Carthagnet nodes, right? So Carthagnet is again our testnet. It's not a mainnet. For mainnet, you need to create a wallet. You need to get actual real Tezos, either from a faucet, mainnet faucet, or you can buy it on exchange, or somebody can gift you, right? So that's how you have to do. I'm just walking all of you through the process of, let's say, activating that account, right? So once you download this tester GUI, all you have to do is you kind of run that tester GUI. You click on click start, right? If you are using a local node setup, right, if you want to do everything on your local node, you have to download tester CLI as well, which will run all the local nodes for you. As of now we support only Linux, right? But for remote nodes you can use it, so you don't have to have tester CLI if you want to connect to remote nodes. So let's say we connect to Karthadnet, right, through tester node. So in the GUI, right, I switch to Karthad tester node. Then I click on add faucet account, right? Here we have already provided the link, right? I have to just fill out these fields. So let me just copy it from the faucet account that we have downloaded, right? So first is mnemonics, right? So as I had told you when we were talking about, let's say, private key and public key, right? That how private key is generated. So private key is generated through these 12 words. So in your faucet JSON, if you have seen, right, there are, I think, 12 words, right? So this 12 word helps to create some kind of randomness or entropy, right, in the private key it generates. And if you change the order of this private these words, right, your private key will change. So essentially you have to make sure that you are saving all these words in the same order in a proper fashion. And with the spaces, even if you remove space, it changes. So now again, going back to the JSON part, right, I'll have to get the secret as well. So I copy the secret from there, I come here, I paste it in the secret field. Similarly, I get pkh, then I have to get the password. As this is a fundraiser account, right, this is a faucet account, you have to have all these fields. If you have a simple wallet, right, then you don't have to go through all these fields, right? That also I'll show you in a while. So once I have filled all the fields right here, I have to give some name, right? So let me give you GDG demo account, to just to identify this account on my app, right, which is the tester GUI. So once I do this, what I have to do is I just have to click on activate wallet. Okay, it looks like it has been already activated, right? It shouldn't happen, but yeah. Okay, I think I'm running through some error, but no problem. Yeah, so what you can do is, again, you can go through this flow, right? I don't know, I'm facing some issues with it, but it will add your account. I already have, let's say, some already activated account, right? So let me just take that, and probably I just try to use that. Just give me a moment. If your account is already activated, right, you just have to go and restore it, right? You don't have to click on activate. If you click on activate, I think it will throw error for you. But I think all the accounts that you download from the faucet, right, those won't be activated by default. So you have to go and activate those. Let's say I just give name demo2 and I click on restore wallet. Yeah, it has, if you can see, right, successfully restored. It shows me balance also for this account. I won't be able to zoom in on this, right? But yeah, I think you are able to read the text and everything. So what I've done is any of the faucet account, right, I have activated and I have restored it. Now I can see this balance. If I, let's say, click on these keys, right, it will show me everything: public key, secret key, public key hash. So as I had told you, right, secret key is here the main part, right? You will need it to do anything on the blockchain. So you have to either make sure that you secure your secret key as well, or mnemonics, right, that we had seen, those 12 words. Those are very important, right? So not your keys, not your tokens, basically. And this is the public key hash. So with this I can go and look this account, right, on a blockchain explorer as well. So if I enter right here, see, it is showing all the details like balance and everything. Then see how many transaction it has done, how many contracts it may have deployed using this account, any other transactions, right? So that's how it works basically. Okay, so going back to our tester app, right? Now let's say we want to deploy our smart contract. We have restored the account. We have all the keys to deploy the smart contract. So what we have to do is we have to make sure that we are pointing to the remote node, right? Karthadnet node. You can either use tester or SmartPy node. Both are remote nodes running for Karthadnet. If you are running your local setup, then only you have to point it on local node. I am running a local node setup, and hence I get the option. Otherwise you'll get a message saying that you have to run the local node setup first, right? Then I have to select an account to deploy the smart contract from. So I have this demo2 account. I'm just selecting that account. It shows me what balance it has, right? Then I have to, either I can provide a contract file or I have to enter the contract code. So if we go back to, let's say, our IDE, I have to go to SmartPy ID. It has this Michelson code right here. It gives this copy button. I think it is taking a while. This session will be there. All the links will be there. So don't worry about, like, if you forget, right, you can always refer to this session whenever you are trying to do it on your own, right? I'm not sure whether it's sharing my screen or not. Let me share it again. Once you go to, let's say, IDE, right, you have to go to Michelson tab, right? Here you click on code. It shows this Michelson code. Just click on copy. I have copied it right in my clipboard. Let me go to my tester app, right? All I have to do is paste code here, right, in the box. So as you can see, I have pasted this code successfully. Again, I have to give a name to this contract, right? So why I'm giving name, it just to kind of refer it in my application, right? This tester app. In real world, you can't you can't name a contract. A contract will be known by its address, right? That I'll show you in a while. So let's say I just give contract label to hello1. I can also always send some amount when I deploy a contract or call a contract. Here I don't want to send, right? If your application DApp is such that whenever you deploy a contract, right, or call a contract, like a user has to send balance, right, then they can send a balance to the contract as well, right? Then it shows that what kind of argument I have to pass, right? So it just shows that I have to pass a string. Also, whenever you pass a string, you have to enclose it into double quotes. Let's say I pass GDG Gwalior, right? So yeah, I'm ready. So I have given the account. My node is pointing to remote Karthadnet node. It could be Tester, it could be SmartPy. I have given my Michelson code here. I have given contract label. Amount I want to pass is 0, right? And I have given my initial storage. Basically, this is the same as passing arguments to constructor. So my code, once I deploy it, right, the smart contract will hold this string. So let me click on deploy contract. Once probably this contract is deployed, right, generally it takes up to 1 minute to confirm the transaction, right? Why? Because that's how our baking works. If you remember, right, I had told you in Tezos, time between two blocks is a 1 minute. So only after 1 minute a block is baked. So sometimes it may take time up to 1 minute to kind of your transaction or contract to be deployed. Okay, if I go to Blockchain Explorer, it shows me that my contract has deployed. There is some issue with the tool, it seems like, but yeah, most of the cases it gets deployed right very quickly. See, this is the contract that I had deployed, right? It shows the storage as a GDG Gwalior. Its address is KT1 something, correct? You can just take a look at that whole thing. Right, so as you can all see, like our contract has been deployed successfully, and it has the storage right that we wanted to send. Cool. So how to, let's say, call this smart contract, right, using the tool. So I do have a previous smart contract that I had deployed uh, using the tool, right? So let me just share that with you. And another smart contract using the same tool that I had deployed. Yeah. So what I can do is, okay, I think it had stopped sharing my screen. I don't know why. Yeah. So here what I have to do is it will show all the deployed smart contract using this tool, right? In the drop down, I can select any contract and I can click on show storage. Right. So the storage says Jignesh. I was just trying to deploy one of the smart contract right just before this session. So it had deployed right. Now I can go to invoke contract. So invoke is like calling a deployed smart contract. Again, invoking is a special, like a very simple process. I just go to, let's say, I have to switch nodes, right? I just select my account. I can select a contract, right? Okay, but this contract was on local, so probably I won't be able to. Yeah. So let me just deploy the same contract again. Okay, just give me a moment. Yeah, I'm trying to deploy the same smart contract again. Hopefully it works. Otherwise, we do have local setup, right, where I can run. Sorry for the things, right? Sometimes it goes wrong. Yeah. Okay, it looks like it has some issues. Let me switch back to my local node, right, where I had deployed the smart contract. So I can go and check the storage for that. Okay, seems it has some issue. Okay, so this is my current storage. I just go to invoke, I can select any of the account. So again, this is my local node, that's why you are seeing different accounts, right? If you are deploying on remote node, you have to choose the account that you have downloaded from the faucet, right? Then you can select a contract here, right? You can select the amount that you want to send, and then entry point, right? So if you have multiple entry points, it will show you different entry points. Otherwise, it will just show you the default entry point, which is only one. Now I can change it to so the earlier storage was Jignesh, right? So now what I'll do is I'll just change it to, let's say, uh, Jignesh is not, I'll just give it to demo session. Right, as it is a string, I have to enclose within two quotes, and I can just click on invoke contract. Right, it says that, say, it has been successful. Right, I say okay. Now I go to view contract storage, and I click on show storage again. See, it shows that it is demo session. Right, I can go and check the transactions as well. So I can select any account, right? And when I click on show transactions, okay, this account one doesn't have. If any other account has, it will show the transactions for that account. Yeah, see, Bootstrap 3 has some transactions, so it shows that. Okay, so that's it. The other thing that you so yeah, that's how basically you can deploy your smart contract, right? I know, I think you may have got confused with some of the things, but you can always refer to these videos and the tool guide, right, that I had shared through links, right? To get the whole feel. It's very well documented. It shows and explains all the steps. It has all the gifs, right, of doing all the steps. Other thing that you can do with this tool is you can also transfer Tezos from one account to other account, right? So before transferring, right, let me just go and check the balance for all the accounts. Say it shows balance, right? So we'll just pick this smart contract, not smart contract, but account. Bootstrap 4 is its name, right? We'll just transfer some Tezos from this account. So in Tezos, all the precision of currency, right, or the amount is in mu, right? So that is 10 raised to 6, basically. So let's say even if you have to transfer one Tezos, you will have to give 1 into 10 raised to 6, right? Then only you will be able to transfer one Tezos. So if I go to transaction and click on transfer Tezos, I can select Bootstrap 4 account. Then I can select, let's say, Bootstrap 5, right? Then I have to enter my account. So let's say if I have to transfer 10, so what I do is I take 1 and then six zeros. 1, 2, 3, 4, 5, 6. Okay, then I have to give guess price and guess values, right? So these are something of some kind of a limit, right, that you want to set. Uh, what's the max amount of fees that you want to pay to your uh, baker, right? So the more fee you can pay, you are willing to pay, the faster your transaction will be committed. So let's say just give me 2000, right? And then I click on pay amount. It shows that it is successfully done, I can just go to Bootstrap 4 and just show transactions. See, it is showing that I have transferred 10 Tezos, right? I can go to accounts and I'll just refresh the balances. See, for this guy, balance has been reduced by 10, right? And for this guy, it has been increased by 10. Why it is not full 10 is some of the balance, right, will always go to your baker, right? The fee that you have paid, right? So that's why it's not perfect like 10, right? Some of the value will go to the baker as a part of a fee. So this again, you have to make sure whenever you're transferring some Tezos to one account to another account. Yeah, so I think probably that's how you can develop a smart contract, right? And deploy it any dApps. Let me take you to through the one of the bundle, right, that we had built. So this is I'm posting a link in chat, and let me share the tab with you guys. This is a bundle that allows you to develop a DApp using React, right? So it has all the inbuilt boilerplate code to kind of build your smart contract code, right? And then parse the Michelson and then call your contract, right? So if you just go through the documentation, you have to just configure it. You just have to provide some node, on what node you have to deploy the smart contract. Just set some of the values, and you can easily integrate the whole code, right, in your React app. So if you just go and take a look at the folder, right, so it has a smart contract folder where it builds and keeps your smart contract. Then client, right? So client is nothing but this is your React app. You just use it the way you normally use any React app code, right? And it already has utils, right? Our developer, right, he has written utils. So these utils you can directly like integrate all the smart pi or consul.js functions, right, in your React boilerplate, right? And to read more about, let's say, documentation on consul.js, right? So which is again a library which allows you to interact with your blockchain using JavaScript, right? So as you can see, I have shared the screen. I'll share the link as well for the consul.js. It has all the different methods to, let's say, create a testnet account, then kind of restore the account, deploy a contract, invoke a contract, all those things, right? So yeah, I think that's pretty much about the whole development, right, on Tezos. So I think, yeah, with all this information, right, and the tools that I have provided, I think you would be able to write your first day. What I want you to do is, once I think probably this session is over, right, you can try out all the things. You can always refer to these videos if you get stuck, or follow through the documentation given in all the links, right? We have made sure that documentation is pretty clear and easy to follow, right? And if you find any issue, do reach out to us on Tezos India Telegram channel, right? Or our GitHub, right? You can just go and post an issue, or for that matter, right, you can even contribute to the tool, and you can raise a feature request, right? Or you can raise a code review request, right, if you want to merge your feature into the open source tool. All these tools that I have shown you, right, those are open source tools. You can write a code to improve it, right, or add a new feature, right? So yeah, that's how you write open source code. I think yesterday somebody had asked, will you teach how to write open source code. So yeah, this is how you basically contribute to any open source code base. Okay, so I think yeah, with this we are going towards the end of the session, right? So we do have one announcement, right? We have a ambassador program, right? Student ambassador program for Tezos India Foundation. So I'll be posting. Yeah, so I think the link is already there for Tezos Campus Ambassador Program, right? So if you are interested to be an ambassador, right, for Tezos India Foundation in your college, right, we'll be doing more of this workshop, right, or let's say detail tutorial sessions, right, or hackathons and all those things, right, or to stay engaged in the community, right? You can be an ambassador and you'll be leading all the efforts, right, in your college or in your campus, right? There is a sign up form. You can just fill that form and we'll reach out to you. And I think I'll just hand over to Om, right, for I think further information on let's say what all you can do with what all kind of D apps that you can develop with the tools and the links that we have provided, right? Or what kind of in general applications you can develop. Now that our hackathon is over, right? But that doesn't mean that you can't develop some cool, awesome apps, right? Development is a continuous process, right? So you can build something cool and we'll make sure that you are able to showcase it to the whole world, right? We'll provide you a platform where you can showcase to all of the community or all of the world, right? So yeah. Okay, so somebody, okay, link is not working. I'll make sure. I'm just handing over to Om. Yeah, if Om you are there, you can just take over. Yeah. Hey Shivans, are you there? Or anybody, any organization from GDG?
Yeah, yeah, I'm here. So, hi guys. This was a very sweet and informative session by technique. But it doesn't end here. I mean, what you have learned is very basic in the beginning to start your journey, to start the development. But I would recommend you guys to keep following and keep building, because otherwise all of this, if you don't process through all the information, if you don't practice, then none of the certificate is gonna matter. So give me a moment. Yeah. So what I meant to, what I wanted to say is that you need to process through all the information, you need to go through, and all the documentation you need to practice at your home. Only then you'll be able to process all this information, and get familiar with all the terms, get familiar with some sort of programming and coding. And you don't need to, if you are already experienced with other blockchains, let's say Ethereum and Hyperledger or other blockchain, then it should be fairly simple for you guys to start building on top of Tezos. And if you are completely new to blockchain, then I would suggest you to practice all the things that Jignesh have explained. Even though if you don't have a lot of experience, you can always ask us questions in Theos in the Telegram group. You can always reach out to us and do practice. I mean, I know some of you guys are going to be getting certificate after that, but that certificate is not going to matter in the real life when you go for an interview or go for something when and you don't know the and you don't know about what you have learned and what kind of app or information that you process. So always recommend it to, if you want to be a blockchain developer, if you really want to learn this technology, we would recommend you to go through all these tools, go through this entire video once again, and build on it, develop on it. Apart from that, apart from that, what else could be done is we also have a lot of programs at the Tezos India Foundation. We are always here to help you guys. But if you show enthusiasm, if you show that you are really want to do this, you are interested, then we will deploy all the resources and all the support and everything that you want in order to be a good blockchain developer, a good Tezos developer. We have all the support and resources. We also organize hackathons very frequently. Even right now, there is a hackathon going on. I'll also drop in the link. It's a coin list versus Tezos hackathon where the prize are worth $25,000. It's a huge amount of prize money, almost like uh, a lot of prize money, I guess. And yeah, so there is a lot of prize money right now. We just concluded one hackathon where it had prize money worth $5,000. So and we are still reviewing those projects, which projects is gonna get the prizes. We've seen many projects, multiple projects, which where people didn't know anything about Tezos, but they still took a time of a month, and by the end of the month, they were able to build something cool, build something exciting, and that is what we enable. We deploy all the resources, we provide you incentives, provide you prizes, we provide you longer term support. If you have any nice idea, we connect you with we connect you with funding so that you can follow on with your idea and you can go forward. So there's a lot of things that we can do. It depends upon what you guys can do for in order to support in order for us to support you guys. We have seen many times. I mean, we have organized hackathons and workshop multiple times, and I'm sure some of you guys are gonna be following us, and some of you guys are gonna be active with the community. We are gonna be active with the development, and which are also gonna be participate in the hackathon for upcoming the hackathon, and it is always great. Apart from that, I what you and what I mean for the new people who are very fairly new to blockchain, what you guys can do is you guys can go through this entire tutorial once again. Try to build very simple smart contracts like string storing, and try to build a web interface. Like we didn't have a lot of time, so we couldn't show you a lot of things. So maybe using Conceal.js, as Jignesh showed you guys, you can build a web app where you are only filling a form like your name, age, or your number, and you're only storing that data in a blockchain, just something like that. Or maybe you could implement a calculator, or maybe you implement very simple, fairly basic stuff, so that you can get a hang of the language, you can get a hang of the JavaScript library, you can get a hang of the interface and the transactions, the basic terms. After that, you can move forward. And those people who already have experience with the Ethereum or other blockchain, or just basic idea, or who has done or who already know the basic development on blockchain, what you guys can do, and the easiest way to build on top of Tezos is you can Google ideas on Ethereum. You can go and take any projects that is been built on Ethereum, be it a hackathon project, be it a normal project, and you can replicate that same project into Tezos using Tezos language, which is smart by using Tezos JavaScript library, which is Conceal.js. Try to replicate the same because you already have the smart contract logic. You already know that from Ethereum contract, you need to only copy and paste in the Tezos format here, and then try to build that application in the Tezos ecosystem. So these two are the best way to practice for new people, for new developers. You guys can always try very basic, simple smart contracts. And for people who already have some experience, you guys can take references from Ethereum or you can just simply Google Ethereum project ideas for a hackathon, and then you can get a lot of ideas. You can get a lot of GitHub repository, and you can try to implement it on top of Tezos. And when it comes to ideas for hackathon, there are always very defined tracks like identity management, like decentralized finance, like NFTs, payments and stuff like that. But once you know all the basics of blockchain, once you know the basic interface and the basic development and deployment, then it will be easy for you guys to understand what is DeFi, what what logic do you use, what algorithm do you use in the DeFi. DeFi is basically decentralized finance. And then what are NFTs? NFTs are blockchain tokens for game. Like in the real world game, you earn some collectibles like sword, or you earn some mango or some flower, and it has a real value. Like you buy those collectibles for 10 rupees or 20 rupees. But in blockchain, those item works as tokens. Those are called non-fungible tokens, and it is a huge use case in gaming. So that once you buy a sword on a game, it is always going to be yours until you transfer it to someone else. Usually, what happens in games are very centralized. So let's say if a game decides to delete all my gaming history on Call of Duty, then all the progress that I've done is completely lost, and all the guns that I've achieved, all the bombs and grenade I achieved, they are all lost. But if you try to implement blockchain factor into it, if you try to put all those collectibles like guns, grenade into NFTs, then you would never lost it because it's on blockchain, and you would always be progressing in your gaming history. So there are many amazing use cases in gaming, in finance, like how can you send money from one person to another? How can you request money from, let's say, payment? How can you send money through a WhatsApp like chat? So many use cases around that. Then you have identity like or data miner. I mean, more of like a self-sovereign identity where you give your information to, let's say, an airline to book your ticket, but as soon as your flight is done, you can delete and you can go back and delete that information. So all these use cases are possible with blockchain, and there are many multiple scenarios. But again, I would say start very simple. Start now. Start simple. Very basic. If you have doubts within the basics, reach out to us. We'll help you guys to clear your basic concepts. Once your concepts are clear, once your basics are clear, once you are able to develop and interact on a very basic manner, like simple strings, simple numbers, simple integers, then uh, then you guys will be able to move forward till gradually increasing the complexity of contracts. Again, I would say join our Sneha will provide all of the links. We will also circulate the form. Okay, do if you really want to be involved in the Theos India Foundation, if you want to be involved into what we do, please join our campus ambassador program, and you will get many T-shirts and merchandise and many things for the sake. And we have a lot of incentives for the people who wants to help the community, who wants to spread out the word, who wants to bring more developers into the ecosystem, and who wants to learn a lot, who wants to grow their network, and everybody who wants to grow as a person or increase their soft skills. So thanks again, guys. Thanks a lot to Jignesh for I mean, he has given a significant amount of his time to take you guys through and all the basics of blockchain and Tezos deployment. If you have any questions right now, you can ask me any of the questions, and then we'll conclude the session. And we hope to stay in touch, and we hope to see you participate in our upcoming workshops and upcoming hackathons. Please shoot out any question if you have for us right now.
If anyone of you are having some questions, then please ask. We have our mentors here. Do ask the questions. If you have any, do ask your questions.
We will also try to share a brief short of assignment. Maybe I'm also thinking about saying we will try to share a short assignment so that you guys can do that assignment and put your and upload the solution in your GitHub and send us the link over the mail or to the GDG Gwalior group, and we will assess this assignment, and then we will see who has put the efforts, even if it's wrong or right, and then only we will proceed forward to providing certificates. So
Okay, so we are ending to this session. Thanks a lot to our speakers, Om sir and Jignesh sir, for putting their time and helping the community. The links of the selected students will be disclosed on our Instagram page. So please do follow GDG Gwalior on Instagram for the winner list. And if you have any such questions, then please do ask in the comments. And for certificates, those who are asking for certificates, please do fill the form that we have shared initially. I'll be posting the link again, and if you want the certificates, then do please fill the form.
yeah, okay, Santosh. Please join our group, and we'll share as many resources as we can. You can also reach out always to our community manager Sneha. She will also give you all the resources to learn blockchain and keep you also send you tutorials about how to develop on top of Tezos. I see no questions as of now. Yeah, guys. So I mean, we are very active everywhere. So even any of you want to reach out, you can reach out to us on Telegram personally. Uh, yeah. So I guess so. I see there is a question from Priya. Would you keep the session for professors so that should sure, definitely. We also do organize. I mean, we have also done one session for the professors in IIIT Hyderabad, and we will let you know if we are organizing any such session. If you are interested, you can also reach out to us for this kind of session for faculty of all the professors. We are already in touch with many universities. Always a pleasure to to provide this information and provide this upcoming technology for the to the enthusiast. Again, guys, I would like to thank each one of you for being such a nice audience. Thank you, GDG Gwalior. We will provide all the links to Shivansh, and maybe he will share all the links for some resources, for Telegram channels, and for Twitter, everything, for LinkedIn. So that you guys, so if you guys have any more question, you can always reach out to us and stay in touch. Keep building, keep practicing. If you don't practice, then again it's going to be hard to find your way around this technology. So keep practicing and ask us any doubt or any question that you might have on Telegram or on GitHub or any way that you see fine. Thank you, guys. Thanks again. I guess with that note, we would like to conclude the session.
Okay, so we are ending this session. If you still have any doubts, you can ask in comments. We'll try to answer it as soon as possible. And please do follow our Instagram and LinkedIn page. We'll be disclosing the list of winners on our Instagram page. So please do follow there. Yeah, I think that's it.